Hello everyone. After obtaining initial visible solution in a transportation problem by using northwest corner rule method or least cost method or Vogel's approximation method, the next step is to test the optimality of the initial feasible solution or initial basic solution. So basically, to test the optimality of initial basic feasible solution, there are two methods. One is stepping stone method and another one is modified distribution method, or we can call it Modi method. So the basic condition of using these methods or initiating these methods is that we should have an initial basic feasible solution. So what is the meaning of initial basic feasible solution? It must satisfy two conditions. First condition is that the solution should satisfy all the rim requirements. Like in this particular table, we have calculated initial basic feasible solution with the help of northwest corner rule method. So this solution has satisfied all the rim requirements, like the sum of all the rows is equal to the supply requirements and the sum of all the columns is equal to the quantity demanded. So we can say that this solution has satisfied the rim requirements. The second condition of basic feasible solution is that the solution should have m plus n minus 1 number of basic variables or occupied cells. In this particular table, m denotes the number of rows and n denotes the number of columns. So number of rows in this question is it is 3 and number of columns are 4. So the number of occupied cells or the basic variables should be 3 plus 4 minus 1, that is equal to 6. So by using these two techniques or by using these two methods, we can identify if we have an initial basic feasible solution or not. So in this case, the first condition that this solution satisfies all the rim requirements, and second, it has 3 plus 4 minus 1 number of occupied cells. That means it has 6 occupied cells. You can count 1, 2, 3, 4, 5, 6. So this solution has 6 occupied cells or basic variables. So this solution satisfies all the conditions to apply stepping stone method or modified distribution method. So in this particular video, we are going to learn about the stepping stone method, and in the next video we will discuss about modified distribution method. So basically, in stepping stone method, what we have to do, we need to calculate the opportunity cost of all the empty cells. You can see here in this table we have 1, 2, 3, 4, 5 and 6 unoccupied cells or non-basic variables. So in stepping stone method, we need to calculate the opportunity cost of these unoccupied cells, and on the basis of that opportunity cost, we will test, or we are going to test the optimality of the solution. So let's start the stepping stone method. In the first step, what we have to do, we have to calculate the opportunity cost of the empty cells one by one. So firstly we are going to identify the number of empty cells, that is equal to 6. Now we are going to give a name all the empty cells. So suppose this one is the empty cell. The name of this empty cell is S2D2. S2 means second row or second supply point and destination 1. S1D1. Second empty cell is S2D2. S2D2. Third empty cell is S3 and D1. S3 D1. Fourth one is S3 D2. S3 D2. And fifth one is this one, S3 D3. S3 D3, and the sixth one is S1 and D4. S1 D4. S1 D4. So in stepping stone method, we have to calculate the opportunity cost for these empty cells. We have given them a name, S2D1, S2D2, and so on. So let's start with the first cell, or we can start with S3D3. First, calculate the opportunity cost for S3 and D3. What is the meaning of opportunity cost? That if we talk about specifically about S3D3, earlier we have not adopted this route, or we have not assigned or assigned any quantity through this route. We are not transferring any unit through this route. So what is the opportunity cost of not using this route? That's what we are going to calculate. And how we are going to calculate it? It is the most important part of this numerical or these type of questions or transportation problems. We must know how to calculate the opportunity cost of the empty cells or unoccupied cells. So let's start with S3D3 with this particular empty cell. And the first step to calculate opportunity cost is to let's suppose that we are going to assign a single unit to this cell. We just assigned a single unit or one unit to this cell. It means we are transporting one unit from source 3 to destination 3. Okay. So first step is assign a single unit to an unoccupied cell or to an empty cell. Now look at the rim requirements. The demand for destination 3 is 350 units. 350 units. After allocating one unit to this cell, the sum of D3 column became 351. But what is the condition of obtaining solution in a transportation problem? That it must satisfy all the rim requirements. It must satisfy all the rim requirements. But in this case, after assigning one unit, the sum of this column became 351. So what we have to do? To balance it out, we should reduce one unit from this cell. We should reduce one unit from this cell. So it became 179. After reducing one unit, it became 350. So we have satisfied the rim requirement of destination 3. But now look at the row requirement. The supply of the source 2 was 300 units, but after taking away one unit from this cell, it remained only 299 units. Okay. So what we have to do to balance the requirement of source 2, we must add one unit to this cell. Okay. Now again look at the rim requirements of the D4 column. Total requirement was 320 units. After allocating one unit to this cell, it became 321 units. So again we need to balance the requirement of column 4 or destination 4. So how we are going to do it? Just reduce one unit from this cell. Okay, like you can see in this way, we have transferred from one unit from this cell to the empty cell. Earlier there were 200 units in this cell, but out of 200 units we took away one unit from this cell and allotted in this cell. Similarly, to balance out the column requirements, what we have to do, we have reduced one unit from this cell, and again to balance out the requirements of this column, we added one unit to this particular cell. So you can identify the movement of the units from this row or from this cell. We moved or took away one unit to this cell, then from this cell we took away one unit to this cell to balance it out. So you can trace the movement of the units. Then we moved from this cell to this cell, and again from this to this. So you can trace a loop, a closed loop from which is starting from empty cell and going to next cell vertically, then horizontally to the next cell, and again vertically to the next cell, and ultimately it is being end up at the empty cell. So before moving ahead, we must understand the concept of closed loop. It is very basic to calculate the opportunity cost of the empty cells. So what is the concept of closed loop? Actually, when we assign some units to the empty cells, then it calls or it requires to make some adjustments in the rim requirements, like we have done in this question already, that we have added 1 unit in this cell, reduced 1 unit from this cell, again added 1 unit in this cell, and reduced 1 unit from this cell. So in a closed loop, the basic things you must remember. First one is that the loop starts with an empty cell. Every closed loop starts with an empty cell. So we are starting from S3 D3. What is the second rule to create a closed loop? The second rule is that you can move either vertically or horizontally. You can move either vertically or horizontally, but not diagonally. You can't move diagonally in this table. You should move either horizontally or vertically. So movement should be horizontal or vertical. Horizontal or vertical. And in that too, you must keep in mind that the movement should be horizontal or vertically. And what's the third point? After moving vertically, you have to move horizontally, and after moving horizontally, you have to move vertically. It means you have to move horizontally and vertically in alternate manner. After moving horizontally, you have to move vertically, and after moving vertically, you have to move horizontally. So in alternate manner, move horizontally or vertically. So in this particular loop, we started from empty cell, that is S3 D3, and we shifted to the next row, upward row, vertically. Then we take a turn at 90 degree and shifted horizontally to the next cell, and again we took a 90 degree turn and shifted to the next cell, and again we took a 90 degree turn and came back to the empty cell. So we came back from where we have started. So it is a closed loop. So basic rules are: a closed loop should start from empty cell, the movement should be horizontal or vertical, not diagonal, and you have to move in alternate manner. After moving horizontal, you have to move vertical. After moving vertical, you have to move horizontal. After moving horizontal, you have to move vertical. Okay. So what is the rule number 4? While creating a closed loop, rule number 4 is that in a closed loop, and in a closed loop, if you look at a particular column or a particular row, then you will realize that, and you will notice that there is a positive sign and negative sign in a column. Like in this closed loop, suppose we are taking this particular column. In this cell, we have added 1 unit, so there is a positive sign. But in the next cell, we have reduced 1 unit. It means there is a negative sign. Similarly, in second column of this loop, that is this one, there is a positive sign in this cell. It means we have added 1 unit in this particular cell, and in the next cell of this column there is a negative sign. It means we have reduced 1 unit from this cell. Similarly, look at the rows of this closed loop. In first row, There's negative sign as we have reduced 1 unit. There's positive sign as we have added 1 unit in this cell. Similarly, in second row, here it is a negative sign and here it is positive sign. So in a nutshell, we can say that in a closed loop and in a particular row or column, there would be two signs. One would be positive and one would be negative at max. So there can not be more than two signs. One should be negative and one should be positive. Why it is so? Because we have to satisfy certain rim requirements. We have to satisfy certain supply and demand requirements. That's why there should be one positive and one negative sign in each row and each column of a particular closed loop. Okay. So I think now you are clear how to create a closed loop. What is the fifth rule of creating a closed loop? You can see there are even number of cells while creating a closed loop. Okay. So all in every closed loop there would be even number of cells. There would be even number of cells creating the closed loop. In this particular closed loop, there are 4 cells. There are 3 occupied cells at corner points 1, 2, 3, and 1 is unoccupied, for which we are calculating opportunity cost. So what is the rule number 5? Even number of even number of cells. So the cells would always be in even count. They can be 4, 6, they can be 8, they can be 10 or 12, but they would never be in odd numbers like 9, 7 or 11. So it is the rule number 5. What is the rule number 6? What is the rule number 6 for creating a closed loop? The minimum number of cells required to create a closed loop is equal to 4. So minimum number of cells required to create a closed loop is 4. There cannot be 2 cells creating a closed loop. So you require at least 4 cells to create a closed loop. And what is the 7th rule to create a closed loop? 7th rule is that there can be only one unoccupied cell, or there can be only one empty cell, and that is for which we are calculating opportunity cost, except that every cell should be occupied, or every cell should be a basic variable. Okay, you must keep in mind all cells should be occupied except the one for which we are calculating opportunity cost. Okay, these are some basic rules that should be followed while tracing a closed loop in a particular transportation problem. Okay, there are certain other rules there can be 8th rule that these closed loops can be in a squared form, or they can be you can say there can be 4 arms, or there can be 4 cells, there can be 6, there can be 8. So their shape may vary from question to question. Okay, when we move ahead, we will see that there are different shapes of the closed loop. So these were some basic rules to develop or to draw a closed loop while calculating the opportunity cost of the empty cells. I'm going to clear it. So we were calculating the opportunity cost for S3 D3. S3 D3. So we can denote the closed loop, or we can denote the particular cells to create a closed loop. Suppose for S3 D3 we have started from S3 D3 loop, then we shifted to this cell, that is S2 D3, S2 D3, then we shifted horizontally to next cell, that is S2 D4, and again we moved to the next cell vertically, that is S3 D4. So in this way we can represent the path of loop. From S3 D3 we have started to S2 D3 to S2 D4 and to S3 D4. So next what we have to do, simply apply your common sense and apply your basic knowledge about the transportation problems. Earlier we were not using this route S3 D3, but now we are using this route. It means if we are transferring one unit from this cell or from this route to the destination 3, then what would be the cost per unit? It is going to be 11 rupees. So if we look at the effect of opting this route on total cost, then the total cost would be increased by 11 rupees per unit, because we are transporting only one unit. Then the total cost would be increased by 11 rupees. Now look at this cell. Earlier we were transferring 180 units from this cell, but now we are transferring only 179 units. It means we have taken away 1 unit from this cell. It means the total cost is reduced by how much rupees? 8 rupees. The effect on total cost would be that it would be lesser by 8 rupees. Now look at the next row. Again, earlier we were transferring 120 units, but now we are transferring one extra unit. It means 121 units. Then what would be the impact on total cost? It would be increased by 14 rupees. That because per unit cost of transportation is 14 rupees. So there would be a positive sign. Similarly, in this cell, earlier we were transferring 200 units, but now we have taken away 1 unit from this cell. What would be the impact on total cost? That it would be reduced by 7 rupees, minus 7. So now look at the net impact. What would be the net impact of this allocation on total cost? So what would be the net impact? 11 plus 14, 25, minus 8, 7, 15, that is equal to 10. So net impact on the total cost would be 10. And remember, it is plus 10. It is plus 10. It means if we opt this route, then our total cost would be increased by 10 rupees. If we opt this route, then the total cost would be increased by 10 rupees. Then what would be the opportunity cost? It is the net impact or net effect on the total cost. So net effect is 10 rupees. Then if you convert the net effect into opportunity cost, then what would be the opportunity cost? Just convert the sign of this value, minus 10. Opportunity cost is minus 10. What is the meaning of this? If we opt this route, then the total cost would be increased by 10 rupees. It means it is going to bring some loss to the transporter. Okay. So in similar way, we have to calculate the opportunity cost for every empty cell. Now I am writing everything in concise form. For S3 D3, the route was this one, S3 D3 to, or we can write the values directly, because here it was positive sign, so 11 minus sign minus 8 plus 14 minus 7. So net effect was 11 minus 10, 3, 3 plus 14, 17, 17 minus 7 is equal to 10, and the opportunity cost was just change the sign of this value, minus 10. Similarly, now calculate for every other empty cell. Like suppose we are taking S2 D2, S2 D2, and where is S2 D2? S2 D2. It means we are talking about this particular cell. Okay. Now keep in your mind every rule I have told you about tracing a closed loop in this cell. I'm just clearing this one so that it don't look messy. So now we are calculating opportunity cost for this cell afresh, S2 D2. Just now focus on S2 D2. This one is the empty cell. To trace a closed loop, we should start from an empty cell, that is this one. So we are starting from this one, going to the next cell vertically. Then we are going the next cell horizontally, and again coming back to the next cell vertically, and ending up at the initial cell, that is the empty cell, again horizontally. So now to calculate opportunity cost, what we have to do, just assign a single unit to this cell. Like I have assigned single unit to this cell. Then again, to adjust the rim requirements, what we have to do, reduce one unit from this cell and shift this unit to this one, plus and again minus 1. So just remember, it is very simple, that from where you are starting, put a positive sign over there. From this empty cell you are starting, just put a positive sign here, and just opposite to this cell is this one, put positive sign over there. So the cells which are opposite to each other, they would be having same sign or similar sign. So the cell you are starting, the cell for which you are calculating opportunity cost, just put the positive sign, and the cell which is opposite to the empty cell, put positive sign over there, and remaining two cells will be having negative sign. Okay, so we are starting from here. If we allocate 1 unit to this route, what would be the impact on total cost? It would be increased by 11 rupees. We are taking away 1 unit from this cell. What would be the impact on total cost? It would be reduced by 10 rupees. We have allocated 1 unit extra unit over there. What would be the impact on total cost? It would be increased by 12 rupees. And we are taking away 1 unit from this cell. So what would be the impact? The total cost would be reduced by 8 rupees. So net effect would be 11 minus 10, 1, 1 plus 12, 13, 13 minus 8, 5. So net impact would be, just change the sign, minus 5. So what is the meaning of minus 5? If you are adopting this route, the total cost would increase by 5 rupees per unit. So there is no benefit in opting this route. Okay. Now we calculate the opportunity cost for another one. Just clear this one. So it was 12. So next empty cell is, suppose it is this S3D1. S3D1. Okay. Okay. Remember that while drawing a closed loop, you can move clockwise or anti-clockwise. It totally depends on you, on your will. You can move either clockwise or anti-clockwise. Like now we are calculating opportunity cost for cell S3D1. S3D1, it means this cell. Now look at this cell. Remember that the corner points of the closed loop should be occupied cells. They cannot be unoccupied cells. In a closed loop, there can be only one empty cell, that is for which we are calculating opportunity cost. It means only this one. Except this, all should be occupied cells or basic variables. So let's start the loop. From this cell, we have to move. If we are going clockwise in this direction, we cannot stop in this cell because it is unoccupied. So we have to go to the occupied cell. So we have to go this cell. Allot 1 unit here. To balance out, reduce 1 unit from here. Okay. Now, again, after moving vertically, we have to move horizontally. Okay. We cannot go further vertically. Move horizontally to the next cell. Okay. Now take a pause and think. Can we stop in this cell? Can we opt for this cell? Suppose if we opted for this cell, that means added 1 unit, reduced 1 unit. Now again what we have to do? We have to add 1 unit. Because we have moved horizontally already, now we have to go vertically. We cannot go further in next cell horizontally because we have to move alternatively horizontally and vertically. After taking a horizontal turn, we have to take vertical turn. Now look at the vertical side. Do you have any occupied cell? So you are not going to end up in any occupied cell because there is no occupied cell in particular column. So we are not going to stop or loop in this particular cell. So we are not going, we are just stepping over this cell. So where we have to go? We have to continue our path to this cell. Because after going to this cell, if we take a vertical turn, we can go to an occupied cell, to an occupied cell. Okay. So we are stepping over this cell. So it is an additional rule in while tracing a closed loop that you can step over an occupied